So we're given a function that calculates revenue. We're given a function that calculates cost. We're supposed to maximize profit. So we can quickly make a profit function. Your profit is just how much money you're bringing in, subtracted by how much money you're losing for each of these items. So it's 9925x minus the cost. Now make sure to protect the entire cost in parentheses, or else you're just subtracting the first term of the cost, not the entire cost. There we go. And I said x is greater than or equal to 5, so we'll just want to keep that in mind. I can distribute that subtraction sign and then combine like terms. So I'm putting the leading coefficient first. That's a negative x to the third. This is an x to the first power. So this is going to be negative 500x squared. Negative makes it positive. So this x term and this x term are going to add to one another. So that's 14,117x. And then we're subtracting this last term. So this is subtract 8713. So that's our profit. If we need to maximize something, we can find all the potential, not necessarily guaranteed to be 1, but the potential maxes and mins by finding the derivative of the profit function. So the 3 comes down, multiplies, gets reduced by 1. The 2 comes down, multiplies, gets reduced by 1. Was that 117? Yeah. And then the 1 comes down, multiplies, and it gets reduced by 1. And then this is the derivative. We find the potential maxes or mins, called critical points, by setting the derivative equal to 0. I'll just do it over here. And then we solve. So this is quadratic. The quadratic formula is probably the best way to go, because I guess we could try to factor. It's hard to do though. You'd have to find two numbers and multiply to be 42,351, but add it to be they have to multiply to be negative 42,351, but add it to be negative 1,000. So just quadratic formula is a lot easier. So it's negative b plus or minus the square root of b squared. So I'm going to square negative 1,000. So a number times itself is always positive. So that's 1,000,000 in here. And just make sure to Google a quick video on using the quadratic formula if you need some refresher on that. And then the quadratic formula says it's minus 4 times a times c. So 4 times a times c. So that's a negative, because it was negative times a positive makes a negative. So we're minusing a negative. That changes this to addition. We got 169,404. And then we divide that by 2 times a. And so when you plug this in the quadratic formula, if it's set equal to 0, these are the values that would make it be equal to 0. So we got this plus 1,000,000, and then we take a square root, and you'd want to do this. This is what the radical is, so you'd have to solve it twice, once for plus, once for minus. And so I can tell the plus one is going to be useless to us because they said x is greater than or equal to 5. So if we were to do 1,000 plus this and then divide by a negative, we'd have a negative result. So I'm doing 1,000 minus that result that we just got. That makes the numerator be negative. And then we can divide this by -6, because that's what the denominator is. So I plugged in the quadratic formula. I got 13.56. It should be a whole number. So this one rounds up to 14. So my answer, 14 items, because we got to round up. 14 is correct, but I just got to thinking, since the profit function isn't linear, we should check the two numbers that it's close to, because maybe rounding down would actually make it be, would actually maximize it. So you'd plug in 13 into your profit function, then plug in 14 into your profit function. See which one gives you the bigger profit, because we're trying to maximize profit, but 14 does the trick.